So hello everyone, welcome back to my channel MedPath with Piyush, and today we are going to talk about Bacillus. So today we are going to talk about Bacillus, which comes under bacteriology. So today we are going to start with bacteriology. Okay, so starting with Bacillus, how will we start is that we will be describing it under gram positive. Under gram positive organisms, we have cocci, which are circular, and we have rods. Okay, in cocci you have streptococcus, you have staphylococcus, you have micrococcus, you have enterococcus, while in rods you can further classify them into non-sporing as well as sporing. When we come into the non-sporing category, you'll get listeria, you'll get corynebacterium, while when you come under sporing, you'll get clostridium, and the person we are going to talk in this video about, that is Bacillus. Now there are some differences between these both that you need to know, that Bacillus is an aerobic bacteria while Clostridium is an anaerobic bacteria, and as I've already said that they are sporing. So the spores that they form, Clostridium forms bulging spores while Bacillus forms non-bulging spores. How you can remember this is that B is not for B, that Bacillus is not for bulging spores, so it forms the non-bulging spores. So that is one of important points that you need to remember, that how to differentiate between Bacillus and Clostridium, that is sporing type of rods under gram positive category. Okay, so moving forward to Bacillus. Specifically we come to Bacillus. So Bacillus is ubiquitous in the terms that it is found everywhere in soil, food, water, air. Okay, and the two main bacillus we are going to talk about is Bacillus anthrax or Bacillus anthracis and Bacillus cereus. Okay, coming to Bacillus, most of the Bacillus are motile. Most of the Bacillus that you will find, they will have peritrichous flagella like this. They will be like this. They will be having peritrichous flagella. But the only exception to this is Bacillus anthracis, that is non-motile, while all other are motile. Now, what can they cause? Bacillus anthracis will obviously cause anthrax, while the Bacillus cereus will cause food poisoning. Okay, primarily it is a disease of animals. If you talk about anthrax, it is primarily the disease of animals. Humans are a secondary host for it. Okay. So this bacillus that we are talking about, it likes to come first. Like how it likes to come first, I will tell you. It is the first pathogenic bacteria to be seen under microscope. To be seen under microscope. It is the first communicable disease. That is transmitted by infected blood. It is the first bacterium to be isolated in pure culture. To be isolated in pure culture. And it is the first bacterium for preparation of live attenuated vaccine. Live vaccine preparation. So you get this point that it likes to come first in a lot of things. Okay, so it's very important bacteria. Now coming on to the morphology of it. Morphology. It is obviously gram positive, as we have talked about. Comes under rods or bacilli. Gram positive rod. It is non-fastidious, that is non-acid fast. It is non-motile, as we have talked. It is very large. Compared to this, it is 3 to 10 micrometers into 1.6 to 1 micrometers. It is spore forming. Spores, as we have talked, are non-bulging. Non-bulging. They are central and oval. Now, one thing that you need to know about is that these spores, these are inhibited under calcium chloride. Okay, so these spores are inhibited under calcium chloride. Now, next we come to one reaction, which is McFadden reaction. McFadden's reaction. This reaction is important. It is that Bacillus anthracis reacts with polychrome methylene blue. Polychrome methylene blue for 10 to 12 seconds. Then you get an appearance of a bacteria that you need to understand. That here is a bacteria that you will have blue in color due to gram positivity, and then you will find a capsule which is purple in color. Purple and is amorphous. Amorphous purple capsule that you will find. So that is one thing that you very much need to remember. The reaction is done with polychrome methylene blue, not with methylene blue. And you find a purple amorphous capsule. And similarly, if you do it with Gimsa, what you will find is that you will find a purple colored bacteria with a red color of capsule. Okay, so you need to remember it. Also, one morphological feature that you will find is a bamboo stick appearance. So bamboo stick appearance. Okay, next let's come to culture. Coming to culture, you already know that it is an aerobe, but it's also facultative anaerobe. Facultative anaerobe. Under nutrient agar, it will show medusa head appearance. You got to go to Google and see the picture of medusa head. It's a very characteristic appearance of medusa head, looks like snakes. Secondly, on blood agar, it is non-hemolytic. Non-hemolytic. Thirdly, in gelatin stab culture. In gelatin stab culture, due to more liquefaction on the upper surface where oxygen is there, there is an inverted fir tree appearance. These are very much important names that you need to know as it is. This can come directly. That inverted fir tree appearance is seen in gelatin stab culture of which organism? Next is the selective medium. Selective medium, which is PLET. PLET refers to, I'll write here, try to remember it, polymyxin, lysozyme, EDTA, thallus acetate. And lastly, we come to solid media containing penicillin. Solid media containing penicillin, in which we will find a string of pearl appearance, a string of pearl reaction. This is important in the fact that it will differentiate Bacillus anthracis from Bacillus cereus. Also, there is one more point that will differentiate between these two is Bacillus anthracis shows Suscep- It shows susceptibility to gamma phage. Susceptibility to gamma phage. And one more point of difference, if we were to count the differences, this is the first difference, the string of pearl appearance. Second is susceptibility, and third is that Bacillus cereus is motile. I've told you they have peritrichous flagella. Okay, for this lecture, the last topic that we come to is toxins, which is very important. There are two types of toxins. One is exotoxin and one is capsular polypeptide. Capsular polypeptide. Now it is already saying that capsule is made up of polypeptide. So it is made up of D-glutamate. D-glutamate. And it is controlled via plasmid. Controlled by plasmid. That you have to remember PXO2. PX02. Okay. And what it does is that this capsular polypeptide will be inhibiting phagocytosis. Inhibiting phagocytosis. Now coming on to exotoxins. These exotoxins are actually having three factors: factor 1, factor 2, and factor 3. Factor 1 is also known as OF or edema factor. Factor 2 is also known as P or protective antigen. Factor 3 is also known as LF or lethal factor. Now what does factor 1 do is that it will increase CAMP. It is an adenyl cyclate complex which will increase CAMP inside the cells. That will ultimately lead to fluid retention inside the cells, causing edema. What PA does is that it binds to receptors on target cells and provides attachment sites for edema factor and lethal factor. And what lethal factor does is it causes cell death. The exact mechanism of causing of cell death is just not known right now. These three do not act as individual toxins. They act as anthrax toxin complex, which is again you know plasmid mediated and not chromosomally mediated. Plasmid mediated, which again you have to learn PX01. Okay, so guys, in short, this was it for this video. This was the first part of Bacillus we covered, in which from starting we covered the general, the classification, then the morphological features, then the reactions, then the culture techniques, and then the toxins. Okay, for these notes, please refer to my Instagram page, MedPath with Piyush. And if you want video on any topic, please feel free to comment down in the comment section. And please like, share, and subscribe to my channel. And thank you for watching.